Hi there, I am Dhanvan Sagar. Presently, I am a full stack developer trainee with Munstack at Edioda. I've created this web app named Kafene. Kafene is a dynamic store management system for a pharmacy. It lets you track orders, inventory, and customers. This web app is made using HTML, CSS, JavaScript, and jQuery. It has a login and logout functionality. This web app contains 4 pages: the login page, the order listing page, the product listing page, and the user listing page. The order and product listing pages comes with the filter functionality, which dynamically filters the orders list according to the order status and the product list according to the product stock status. The user listing page comes with a search functionality that searches the users according to their first name and the last name. So let's talk about the product architecture. This app is structured module-wise. So that means this app has different HTML, CSS, and JS files for different web pages: the login page, the user listing page, the orders listing page, and the product listing page. I have structured this app module-wise because it would increase the readability of the code and makes it easier to code one module at a time, henceforth increasing the ease of debugging of the code. So now let's talk about the different files used for the different pages in the web app. Under the main folder, I have the login pages, that is the index pages, and folders respectively for each page in the web app. For the login page, I have used index.html, index.css, and index.js. For the order listing page, I have used orderlisting.html, orderlisting.css, and orderlisting.js files. Similarly, for the product listing pages, I have used the product listing.html, product listing.css, and product listing.js files. And for the user listing page, I have used the user listing.html, user listing.css, and user listing.js files. So let's talk about how did I implement the orders filters functionality in the orders listing page. As you can see, I have selected all the filter section input checkboxes in a constant variable named checkbox. Then I have added an event handler to it. Now this function checks whether the check field name is same as the order status of the data coming from the API call. If they are the same, the data is added to the table and the count value is incremented. Otherwise, the data is not added to the table and the count value remains the same. So now let's talk about how I have implemented the search functionality in the user listing page. I have selected the user search bar in the constant variable user filter. Then I have added the event handler to the user filter. Now the function checks whether the user entered more than 2 characters. If yes, now the user details is mapped and checked whether the entered sequence of characters are present in any of the user details data coming from the API call. If the condition satisfies, the user data is added to the table. So now let's talk about what is hoisting. Hoisting is JavaScript's default behavior of moving all declarations to the top of the current scope. So that means functions and variables can be used before they are even declared. Now for example, we declare a variable k equals to 10 and print k in the console, it prints 10. But even if we print k before declaring it, such as k equals to 10 k var k, it still prints 10 without any error. This is hoisting, but this can be countered using the ES6 variables like let and const. These variables don't allow hoisting. As you can see, let p equals to 10, p, it prints 10 successfully, but p equals to 10, p, let p gives an error initialization.